Hello guys, I guess it's one of these junk videos where I'm ranting a bit about optimization and compiler code generation. And again on the ARM and the 3DO, I have an old test. I have a suite of tests here where I'm trying various things. And this is an old thing I did that I'm trying to revisit for some reasons. Because I thought I could rewrite some things in assembly to obsess about performance again. And I was still testing some old stuff. I was testing four methods: the hardware matrix, the software matrix, a software implementation, and these are two software implementations that are trying to rotate points by avoiding the matrix with another trick that I haven't explained. I'm planning to make a video in the future. There is a special method. At least that method works now for a grid a grid box of regular 3D points, but it could be extended for any kind of objects in a regular grid, possibly for voxel splatting too. But anyway, so I did some crude tests a long time ago, and I was looking again at the code and I was trying some things to help the compiler improve a bit. And I was comparing against the hardware matrix. Now, the hardware matrix and the software matrix both have the rotate vertices. And then I'm rendering the points where I'm doing the projection, the division by multiplied by reciprocal. But I'm doing some extra stuff and I'm writing on the 3D video. This has overhead, so in order to properly test completely test only the location, I have this boolean which by pressing the start button on the controller, I will disable the projection and the rendering, and I'll just let the rotated objects points run, which means you will not see anything. If you disable this, there will be nothing on the screen. But to make sure the rotation works, I had to enable it. Yeah, so because it takes a lot of the performance, you don't see the purely the rotation, how much it takes. So I use the same function here, but it has a boolean true and false here, and it's simply this one. If it's hardware matrix, it calls the hardware API. It does its thing. Else, it's called one software implementation, and that could be done better. That could be rewritten in assembly, but I will demonstrate a bit what I have right now. Let's run it on Phoenix. So now it's 20 frames. It's vsync. I will disable the vsync. It's only 20 frames because I have a lot of dots and I'm also rendering them. And I'm software rendering the points on the video RAM of the 3DO and doing extra check to see if they are outside. But if I press start and stop the projection and rendering, now only the rotation is happening. You see it gets a 47 frames. So I will enable them. And now this is the software. I moved now to by pressing the LR D-pad. Not the D-pad, the shoulder buttons. I move to the software end, and that's much slower, 12, and if I remove it, it's 18. So if I move to the hardware, it's 47, 18. 18 for the software. And now, this is the best method. It gets 27, but it's a method that only works with a regular grid of of points. It's not generic for every. I will show you what I'm. And I'm getting some crazy thing like 159 if I disable it. So purely to rotate these points, it's much faster than even the hardware matrix, but it's a hack. So now if I go to the third method, it's similar thing, but it gets 58, 59. It's better than the hardware matrix. But this one is easier to control and only render the things that you want to render. Or only rotate the points that you need to rotate. But those points have to still be sitting in a regular grid. But anyway, the point was different. I was doing various things, and I was tweaking the C code and trying to get some better results on the CPU side. First of all, I was curious and I started looking how would I write that, and I was looking that those are the matrix value. Okay, this is the inner loop, but I'm reading outside of the inner loop. This is the matrix. I'm reading everything in a series, and sometimes you could expect that in assembly you would use the load multiple instruction to load all the values at once in register, but that's outside, so it doesn't matter. All it matters is what happens here. Now you could this x, y, z from the source. These are the source points. Those could be read with one LDMI of 3 register, and maybe you could write 3 register, and I was looking what happens in general. And thinking about it though, this is outside, and I wouldn't bother as much if the compiler doesn't do the best job, but I was looking. And here, the only negative is that you have 9 values here. You need 9 register. You need, if you read all of this, you need 12 registers. Here you need 12 registers ready at least. 13, 14. And those are the registers you can. You also have the stack pointer, the SP and PC, but you're not supposed to. You cannot change the. You can change the PC, but this is the program counter. So you really have. And I don't think I should change the SP. So you really have 14 register, and that's all you have here. And then you have the count that is 15. So I would need to have some thought to write this one to optimally use the register, but still most of the stuff could be in registers, and definitely do some LDMIA for that. Maybe I could store separate here, because I realized that I have to calculate this and put it in a result. If I was to do an STMIA, you would need 3 extra registers. And now the reason I was curious to, I might try to write that in the future in assembly. One thing is I realized, I'll put that here. I'm reading more on the assembly language, and I know there is a MUL, R1, R2, R3, which is R1 equals R2 by R3. Now, I don't remember the other form. I read there is an MLA, and this ARM processor has an MLA. This is a MUL and add. You could do something. I don't remember the format. Does it take 4 registers? Maybe it's something like that. You could say R1 is R2. I don't know if this is the right thing. I don't know if R2 is the thing that you add, if it's R2 plus R3. I need to see that. I don't remember right now. I was reading about it. But I was thinking that, whoa, that's great for matrices. You can do a MUL and the MLA and the MLA in a row and have the result. And maybe do a move, the result as a LSR shift with the FP core. And then store it. Oh, that's going to be pretty cool. And so I was looking at let's put it in the form. Here I was counting. I was looking at the generated assembly and I started looking more stuff. Also, the other thing I wanted to see. Okay, this is the method I found from some old Democentrics, where you can rotate a grid of points without ever doing multiplications. But you have to create 3 axes which are created. Okay, you have to create them every frame, but those are very small. Okay, you have to create 3 axes for, and the number of points they have are vertices, width, height, and depth. And this one is 16. Okay, I have to create 48 values. That's nothing compared to the 4096 points. Okay, and you can create those by, you have to rotate the axis. You have to rotate 3 points using the matrix calculation. Rotate vertices, axis vertices. I think it's that one. So you have to use the matrix multiplication only for 3 points out of 4096 to create some interpolation vectors, and then you can step through those vectors by, there is one way where you create all the points through each axis, all the 48 points, and you combine, you read them. I have to do a video for that, and you just add them at the end. So I'm not going to explain the algorithm now. It's a trick I thought, and I made another version where I try to avoid, since at least it's a regular box, I try to avoid reading from this axis, but I just, in ZYX loop, I interpolate. Yeah, I have accumulated things like this and unrolled this loop. Those 3 things with the axis values outside. But I also do this outside and outside. It's hard to explain. It's like a small interpolation steps. It's like how you would do a 2D rotozoomer, but you do it on a 3D grid to walk around in 3 dimensions on every point on the grid. But those walking steps, interpolation steps, are the 3 rotated vectors, small rotated vectors. And I store the results on the DSTX, Y, and Z, the points. And that, okay, and I unroll it, and maybe I helped the compiler too, in some way. Okay. So that it generates much better code, but it's also much better in the inner loop, although you have a triple loop, but it's mostly counted here and a bit outside. I'm doing things optimally without reading any memory anymore. If these things can fit in the register, and you have P, X, X, Y, and Z, you have 3 values. You have the interpolants, 6 values, 6 registers. You need 6 registers. And you write the results in X, Y, Z. But it's only this DST pointer that is the 7. You need 7 registers here. Now outside you might have to swap some register and do stuff. You do some extra stuff. And you have the PX6, but you also add the PY and PZ. And the PY will work with the PX, and the PY will be affected by PZ. But here it's isolated. And I'm looking at the generated assembly, I think it's that one. And I see something beautiful. At least in the inner loop, it is a triple STMIA, as it should be, and 3 adds. Triple STMIA, 3 adds. This is finally, this is some good code. I wouldn't have written this one better. But if I was going to write it and work efficiently with STMIA, you would have, everything would be in registers. They are always in V5, V7, V8. They are added V4, V3, V2. So in all of these V2, 3, 4, 5, 7, 8 are used, and STMIA V1 exclamation mark to increase. You write all these values. So you have 3 adds. No, 3 adds here. I also see, oh, it was a bit clever. I increased DST. Does it increase? It even have seen that. It could have said, oh, I need to separately increase DST. It have seen that it's writing X, Y, Z that are 3 values in sequence, and then it goes to the next. Okay, here it was clever, because I would expect to not see. I would expect to do an STMII and add V1, 12 bytes, 3 words. But it even saw that basically this is like writing all this with one STMII and increasing. So it was pretty clever here. And I was, yeah, of course this is going to do 160 FPS, 159. And then I was looking here and I was saying, that's the thing that matters. It doesn't matter as much. What happens outside doesn't matter as much. But I've seen I was doing a division to find it. 9 divisions to find those things. And I thought, oh, divisions. But it's on the outside loop, so this happens once per frame. But this happens for 4096 dots. Okay. And I say, okay, maybe this is minimal. But I was curious. Yeah, at first I thought, okay, maybe I'm dividing with something that is a power of 2, so it is doing it with a shift. And then I see, oh, it's doing, it's calling the software division routine. Oh my god. I mean, insignificant, but then I thought, what would happen? Now, those happens to be 16, okay. What would happen? I do -1 because it made sense to me. It makes sense to me that I had to divide with this -1 for some reason. Because you have 16 points. If you have 4 points, and you have a vector, maybe that's not a good. I thought that I had to divide it with -1 for some reason. And you want to find the small vector between A to B. I manually made it in my head but this is A to B. You might have 4 points, but you have 3 segments: A to B, B to C, and C to D. So you had to divide by number of points -1. I thought mathematically that it made sense, else the interpolation would not be accurate. But I thought, out of curiosity, but it happens to not be a power of 2. Out of curiosity, let's force it to divide with 1 point less. Okay. The effect will still work. It's just that it won't be precise mathematically. It would be the vector will be a bit small, but it would be correct as an effect. And this is the only thing I changed outside. Here inside, I thought it would do the same thing. But here, instead of calling this, it's going to do shifts by 4. Probably it's an Indian arithmetic shift by 4. That's what I thought. So I'm going here. I'm gonna build it again. And the thing is, previously we have seen 159 FPS. When I'm not displaying them, when I'm doing only the rotation, not the present. And I thought, okay, maybe I will get the same because it's significant. Maybe I will see how significant it is to make or not to make 9 divisions per frame. Maybe it will go to 161, to 162, to 165. Okay. Maybe it will stay the same. Maybe it's so insignificant. Am I going here? Okay. I have to remove the rendering and projection. Okay. I'm like, why 126? From 159, okay, from 159 to 126, because I thought at first, does it change something in the interpolance? No, it shouldn't. The optimal part is this. It shouldn't affect. In the outside, I was just curious. These divisions, they used to be divisions. Because this number -1 happens to be 15 and not 16, so it stops being a power of 2, so the compiler doesn't know. And I thought it will not do the division, but the whole thing would be the same. Roughly, and it will do the same. And I was like, what? This shouldn't affect this one. But I guess compilers are so random. Let's see which one is it. Here you see I'm doing the division. Maybe I can put a higher font a bit. It's doing the division. This is the old version that does 159. And here I've seen it at some places. It might be a division, but it does. Where is it? Yeah, it doesn't see ASR. It moves ASR, which is fine. It does a shift by 4 to divide by 16. ASR. Where is the third ASR? No, the LSL 16 is the fixed point by FP core. It's that's a macro. It does int to fixed, yeah, and shifts left by 16. I see 2 ASR. Anyway, it does ASR. It doesn't do anymore those division. And I was like, what the hell? You see, things change in the generation. Things change in the allocation of the register, in how it decides to use the register. And I say it doesn't matter. The inner loop matters. Here I see more stuff here. First of all, I'm like, what happened? But where is the? Okay, here it is. Where is it? STMIA 3 registers. Add. STMIA 3 register. Beautiful. And then, oh, whoa! It does STMIA 2 registers. Doesn't add. It does store separately the other one. Wait, what? Here the register were in a row. V5, V7, V8. Here it's V5, V8, and it stores V7. Okay, this is going to increase. It totally changed. Add V5, V7, V8, add V7, V5. It rearranged things And now I'm not doing a beautiful one STMIA. I'm doing an STMIA for 2 register and 1 STR. Why? Because previously, because it has to do the division, something beautiful happened in this automatic optimization, this mechanical heuristic. Let's find the optimal permutations of registers to do our work, but we are missing a lot. It might have come by accident to this, to the right thing. And now, do you understand it? I thought that by forcing it outside of the loop to do this, I wonder if that blew my mind. So you have something that it creates the beautiful code, at least for the inner loop. You change something that will even avoid the divisions. And it's so outside of here that this one should have been, that good generation should have been kept, but probably it changed a lot of the things that happen outside. It doesn't get the perfect permutations of register selection. And it doesn't know it though. It thinks that, yeah, I did the optimal work. Whoever says, oh, the compiler is so clever, it's going to do better work than you can ever do. It's doing dumb stuff so easily. By the way, I was also looking, I was curious about this one. This might be a bit harder too, but I was curious what it does with LDMI, I think. With this one. This is the slow software render version, no matter how much I have expanded it, and I mean there are too many registers, so it's hard for it, but it might not be so hard for the programmer to mostly come to a better conclusion. I was curious, okay, I don't care much that it doesn't do LDMI, but still, for those ones, this is the outside of the loop. Even if it doesn't do a good work, it doesn't matter as much. But still, I would do it because why not? And it does an LDMI, but again, for 2 values, for 2 registers, and it's all random, V1, V6. And then it gets V2, V3, V5, V4, but how does it get? Okay. A3 is the matrix. Okay. It adds 10 hexadecimal, then that's 16 to V6, to A3 and puts it to V6. So here it would be 0, 4, 8, 12, 16. So it goes there. So it gets on V1 and V6. And why is such a random order? Because the permutation of the register to find some optimal register allocation for the variables happens to find this one. So it gets 4 to V1 and 5 to V6, I guess. But then, for some reason, okay, now it has V2, V3, V4, V5 in an order. So the original A3 that is pointing here, it goes 12, 8, 4, 0. They take it backwards. This goes to V2, this goes to V3, this goes to V4 and V5. And okay, you cannot, because they are not in order, you cannot do another LDMIA. But it goes backwards, and I was like, all of these 4 LDRs could be, theoretically, even if you couldn't, it could be an LD decrease before, I think. So you actually you would have to do a, you already did add v6 a310. v6 is here right now, and you didn't put this question mark to go later. You could get the v6 like it is, use it. So you're here, decrease before. First it decreases to m3 and then it gets it. Decrease and gets it, decrease and gets it. It's like like how you would do push, but you do it for pop. And technically, because of 12840, if I'm not mistaken, it could have replaced this one, even if it doesn't get the optimal register, it could have replaced this one right there with this one. I see that it stores v6 for later use. It does a lot of crappy stuff. But since we haven't used this one, but this one, it's fine. I think it's fine. I'm not okay. I'm not sure if decrease goes v2 to v5. Maybe it goes v5 to v2. Okay, maybe this is not. Okay, I don't know much my arm because I remember we do store decrease and we do LDM. Yeah. Okay, I'm not entirely sure about that because I'm still learning about that. But even if it's not the case, you could do one LDMI to get everything. They would be in an order. You would, I don't know. You could do a better job. And here, the only thing what I was saying is doing a MUL and it's doing an MLA and another MLA. It's doing a MUL and an MLA. Oh, but here it doesn't do an MLA. What the hell? MUL, MLA, MLA. Why doesn't it do here an MLA? It's so chaotic. It's so mechanical. A human could write a beautiful algorithm that could definitely perform better. It does LDR. It uses the SP all the time, probably because there are not enough registers. But you could fight. You could fight if you are a human. And get something that mostly uses the register. Maybe one or two things I would read from SP. Okay, maybe I will have to use one or two things from SP. Because if you count all the things, you need 12 values to be ready in the registers all the time. And you need the source and destination. These are two more registers. It's already 14 registers, and you have a problem. You have the count. But I'm certainly sure that this could be written, and it's a very straightforward thing. It could be written much better. At least it's doing MUL and MLA. You see some nice thing that it does. You see that it does. It's good with the comparison and the not comparison. I have seen some bad things. Okay, I'm not entirely certain if this could be happening with a decrease. Maybe the order is the opposite again. But it's there. Because I noticed something when they use it from the stack and return, I noticed something that was weird and I haven't thought it well. Here it does store decrease before. Decrease before it's like a push. But it should go in an order, V1 to V8 and then LR. It's not the order that you type the stuff, it's the order that the registers are. Something that I had a bug before and then I realized that, okay, that's how it works. So it would push V1 from the right side to the left backwards, V8 LR, and it would do LDMII, V1, V8, PC. But no, from bottom, LDMII, increase, it's like a regular pop. there was some terminology, full ascending, full descending, and empty ascending, empty descending. I'm reading about that. It's one form. It's similar to x86, z80, and all other. And now it's popping the values v1, v8, bottom up. But here is what I noticed. If you do a decrease store, v1, v8, wouldn't it be v8, v7, v6, and so v1? Because you start from high and you decrease. But then this wouldn't work. Because it would expect v1, v2, v3, v8, and so on, and PC, of course. So maybe I need to see that. Maybe if it's a store decreasing, it's going to take the last one going to the previous ones. So it would have to store them like that for this to work. So okay, maybe my assumption for that doesn't work, but you could still have said, okay, god damn it. Even if it doesn't work, you could say add v6 a3. Okay, no, LDMIA. Look, all this block. LDMIA. What do I want? Oh, it's opposite v2, v3. Okay, it's reversed. Damn it. Yeah. Okay. I thought I could do an LDMIA and get that stuff. It doesn't matter, because I would have rearranged my registers so that they are in order, and so that they are in order and they are optimal for what I want to do later, if you get me. The thing is, I see here later, and it's reading a lot of from SP. I can't explain. Oh, I wanted to show you something else. First of all, sorry, okay, I remember what I wanted to say. I see it's kind of clever. It was clever with the MLA most of the time. That, okay, this one can do for matrix calculation and so on. I can do a MUL and add together efficiently. And sometimes it's clever with the conditional versions. So you have an add and you can do an add less than equal, and then it does an LDMII less than equal. So this is the same as this one, but with a condition. It does some clever stuff. If it compares with that, because I have a check that, okay, if it happens for some reason to have a zero or negative value, just return, don't do anything. And it does the comparison. It does the comparison with 0. But that might also give less or equal also. Yeah, because it... Yeah. It might affect the flags in such a way that... So it does this and this. It does both of them with comparison. I see it does some good work with comparison. It might not be the best. I don't know. I'm still learning. And okay, maybe forget about it because it works the other way around. But no, I don't think. These are things in order. It could have done it. And this is a mess. I think this is a mess. I think you could put the thought in. But the most surprising thing was doing this thing right and then doing it wrong. One final thing. You wonder sometimes that where have I seen that? I was testing here. Here I'm doing a for loop. But many times you hear, and that's not a standard, many times we hear, you know, you can help the compiler, even on x86, it's not always the case. I've seen all kinds of things. If you replace your for loop with a while loop, that goes negatively. If you can replace it without altering something inside. Here I'm doing the positive loop and I'm using the coordinate on the table. So if you can replace it, and I don't think if I have tried it here, you would get better speed, but here for some reason I did it with while. I could do it here too. Instead, I could set this to a... But you don't know how the compiler will... I could set it like that and then say minus AX so that I don't have to use the index of that one. It can go the other way around. I'll try that later. But you see, sometimes it's not easy to replace the for loop with the while. It's easy, but you have to change things. Here, the way I have written, and I don't use the X. Not this one, but the pure X. Or the Y. I don't use them. Don't look at this one. So I didn't do while, and I don't know if I tested. Maybe I did test it, and it was okay. Maybe it was the same speed. Sometimes it's the same speed. But why? Because a for loop, for a for loop, you have to say move a. Yeah, I'm just gonna put some pseudocode like index 0 inc. This is not ARM assembly. This is some pseudo, and you have to compare with index 1, not with index, with size or something. So you would have with vertices width, for example. You have to put that like that, maybe. Now this is some pseudocode, okay? And the idea is you have to compare and branch above. And if you do a do while, you put a big value, you decrease, you have to put pseudocode, okay? You do on the ARM assembly, you do that, some kind of decrease. You put the S to say affect the flags, and you do a branch not equal above. And now you spare yourself a compare. So help the compiler with a do while to do its job. And I was looking again. It's a big one. I have to do the do while. I find the do while. And I think here is the do while. Okay, here is the BG. It's a bit far away from some of the compare. And see, it's sub A1 subtracts it 1 and compares it to 0. And does branch greater equal. No, I might not know my ARM assembly, but I'm like, wait a minute. Why not remove that? Maybe I don't know. Maybe I'm missing something from ARM assembly. Now, where you do that, it will affect the greater equal. Is there a no 0? I have forgotten. Okay, maybe I'm missing something. Okay, maybe I have to do it myself. Maybe I didn't help the compiler. Maybe I have to put the do while at the end. So I'm self-correcting myself. What if there is a there is a branch if not zero? Is it a BNE? Not equal? I think it isn't. With my poor knowledge of assembly, I'm like, why does it do the do while with a regular sum and a compare for zero when it doesn't need to do the compare for zero and it could just do the. I don't think this one does that destroy the flags. I don't think it destroys the flags. Maybe I'm missing something. Now that cannot go above because it has to sub and it also stores the A1. Why does it even store? Maybe it doesn't have residence. I'm suspicious here. Okay, I'm suspicious. I see more things. First, it did, and I'm always thinking someone might say because there is this belief that the compiler is doing great work. There are all these engineers with all these complex algorithms. And you think you are better than them or something. Maybe yeah. So I had my doubts when I saw okay LDMI STMI that doesn't work the way you think. So maybe you cannot do those 4 LDRs with a decrease. But then I see that other thing, and then I see that okay, but here I had something that really did what you should do. Why changing that to that so that it's a power of 2 and it doesn't do the division outside? Why did it affect this part? I mean, maybe I could do a last test. Maybe I could do a last test and it's not easy to do it because I'm going to create a monstrosity. I don't think that would do it. So my idea was to do this in another function and then pass it, but then I have to pass 9 values, which is horrible. I don't know. I don't get it. And the thing is, it's very possible that even the way it is, if for some reason I get this here and put them here, it will totally change the order. These heuristic algorithms find the most optimized register to choose and it will break it. So you change things that are insignificant because it could have done the same things for those, find the values in the same registers, and then do what it did before. Just don't do the division, do a shift. There is nothing that changes from the programmer's perspective. Such small changes outside shouldn't change the generation inside. But, you know. So it again makes me think sometimes you have to write, especially in old platforms, you have to write certain things in assembly if you want to make sure. If you want to hit performance, okay, but if you want to write something casual in C and you have good performance enough, you are like, you don't need to write the entire thing in assembly, but these are brute force algorithms that are doing rotating a lot of points, okay, and who knows what code is generated for the projection and how much better it could be. It's not an easy task, but here is another point where today I'm looking at it and say, the belief that the compiler is this optimal beast that is okay, it doesn't generate the perfect thing, but it generates the near perfect thing. No, it has some clever algorithm that generates things that seem clever, but a lot of time it's messing things up. And I believe the same even for modern compilers. Because what people do, people go in God bolt. Everybody has a story that I went in God bolt. I was trying something too. Huh. I went in God bolt. Is this the one I was trying? They write something. I don't remember this one being mine. See, I could have done a STMIA to fill that, and it does store, and it's even on R3, 16, 32, later, before 4, 8. It's like I'm, yeah, that's a bit silly. It's like I'm writing. It's not even beautiful. It's like the compiler is writing here, no, here, 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 here. But I'm preparing things and I'm writing in order here, 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 and I'm even packing things and I'm writing here, here, here with STMIA. I'm preparing things. Those are 0. Maybe it's someone else's code I have seen. I don't know why I copied that. This is from. And then regular STMIAs. And it's doing STRs. Separate STRs. And what I don't know is, okay, maybe because these are modern ARM compilers, maybe they don't do the STMI anymore. I recently read those STM-LDM instructions don't exist anymore in, I think, in the 64-bit ARM. Maybe even before that, even from ARM v. Yeah, but look, I'm setting ARM v70 DMI. I think I read that since ARM v8, you don't have this. Is it ARM 8? I don't know if this is the thing. It still does the same. Is it ARM v4? I don't remember. I don't remember where I got it. So maybe there will be always someone who says, yeah, the compiler is great and you must not know something. Because yeah, I don't know a lot of things. But I recently read that those STMI thing, this is not a thing after ARM, from ARM v8. And they have some other, they have the STP and the LDP, I think. Which is for pairs, it's like STP R1, R2, and that's it. Maybe STP on R0, R1, R2. It's like a mini LDMI. Eh? For some reason they removed it, for some decision on how they design the hardware to be more simple. And maybe other people say, the compiler don't do that anymore because these are not very efficient anymore. So you think you are clever from the compiler, but maybe you don't know enough because they are experts. The thing is, I couldn't find something. It doesn't matter. For the 3DO, I want to be able to generate this one. Okay. Because I was gonna get a GCC and try to compile some of these functions to a binary or extract the assembly instead of the compiler will use, and then inline it here to see if maybe with GCC certain function could be improved a bit. Even if I have to manually make the GCC, of course target the old processor. I have to find an old version of GCC to target the processor we have on 3DO. See if it generates. I'm curious if it generates from this code, if it generates better stuff or the matrix stuff. I will be curious. But then I realize it's going to be random. It's going to be A0, okay, E00, 1, 2. This is going in order. These are, even in the compiler, these are in order. Linear. The easier would be, I guess, to not do it with structs and write in a pointer and increase. I don't know. Why even this one does random permutation? It's writing here, below, below, above, below, 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 below. It goes later. Why is it so random? Okay, it's not so random. It's R1, which is that value, and the other is 0. Okay, there is a bit more order with that, but fine. To do an STMIA, okay, it has to can do 3 STMIAs again. And people are looking at Godboard and they come out and say, I saw something clever that is beyond me. The compiler is beyond me. It's over. And I don't think it's the case. People are impressed by gimmicks. It's the same as ChatGPT, where you are impressed by something and you think that you saw the light. You think that, okay, there was that day in my life that I was convinced that these machines are much better than I will ever be. And I don't think it's the case. It's not the fear of the machine. It's not. I see the generated code. I see. I have some skills and I have some experience of fighting with old school hardware, Z80, x86, and now a bit of ARM, and I realize how I can put my mind and make something beautiful. You know, like for example, I was trying to write some cell code, and I end up calculating everything on STMIA. This is A2 to A4 and V1 to V5. I found the configuration that I could do these things in some kind of order so that I can do one right. Now I have to do 4 LDMIs, but at least it's not 8 LDRs. I have to do because those are 4 separate points. And I'm passing 6 stuff, but okay. And it happens that on my experiments 3DO the structure is different, so it's a bit better. Because I happen to pass the point struct that has the 4 x and y coordinates for the 4 points of the quad together, so I can do this. Is comment out. I found a way to do all of them. Yeah, those have to be in order, and I'm writing them in order because you could get into trouble. And then an STMIA. Probably it's in order unless I commented out to change stuff. and I left it there because for some reason I couldn't rearrange to get those two last. Now they are last. Anyway, I found some optimal ways that are, the compiler doesn't generate that. It doesn't. Here is my flea update with a lot of, you see it's more ordered STMI, but this does copies. And things can be improved. If I look at that stuff, I might think of better ways. And anyways, I believe that if I try to write some of this software rendered function in assembly, we can get better speed. I was curious. That was the hardware speed when I disable. That's the software speed, but those are doing the matrix multiplication. These are tricks that don't do the matrix multiplication. And this is the regular one, and this is the hacky one. Can rotate at least this order dots faster than the hardware. But the thing is, in a real geometry, you might not have this order dots, so you might not be able to do it. But I'm thinking in Bizarro Underground, I have the grid points at least of the map are in ordered position, but I need to make sure because the numbers are. I could replace them. I could gain something. There is a possibility, and it's funny. It's funny if I could, in a real world experiment, in a real world application, in Bizarro Underground in the game, I could. I could optimize the performance of the rotation so much that I go beyond the hardware matrix, but only for regular grid points. But you could construct certain geometries that are sitting exactly on some regular grid points. And this could be good for voxel splatting, I guess. So, but I would have to skip the points I don't want to render, so there is more thought. And anyways, I have more. There is a lot of thought behind those things, but there is frustration with all this thing about the compilers. Not because there are myths. There are myths. There are myths that compilers are gods, and myths about a lot of things, about performance, about we have solved it and you don't need to care about performance anymore, whether it's in low level or high level, even high level. And it's all myths and anecdotes, God bolt anecdotes, and that's it. Anyways, bye. I think this video has become larger than I would want, but it's okay. I had a long time to make a video. See you.